go live. What if we put pop-up here? Can we minimize this? Yes, we can. Alrighty now. Hey, welcome back to the Caribou Data Science channel. This is actually my second live stream of the day. I did a live stream earlier that had to do with how to use ChatGPT and Code Interpreter to do data analysis. I'll put a link to that video in the description below. Tonight's session is going to have to do with using ChatGPT 4 Plus and Notable. And let's just take a brief look at the data here. My hope is to keep, one thing it did, it really shortens the development. ChatGPT and Notable and Code, man, it really shortens the time it takes to get from A to Z. The time it takes to produce a basically very good report, including plot, including visualizations, and including summary statements and stuff like that. Okay. First of all, let's just take a look and see what this says here. Take a brief look at the data. U.S. states. List of states and territories of the U.S. states. List of denonyms for the states. I think denonyms is basically the nicknames, what the people are called. In Ohio, the people are called Buckeyes, so to speak, okay? And a list of the states and territories' name etymologies. We're not so much concerned with the etymologies as we are with just this first thing, which is the state's name, because you can see we got the state name here. It's really all we need. Postal abbreviation. Capital city, largest city admission, when it was admitted to the states. Population, total area of the state in square miles, total area of the state in square kilometers. The area of the state that is on land in square, the area of the state is on land in kilometers. The area of the state occupied by waters in square miles. The area of the state occupied by the number of representatives, and the official name of the state. This is a little disappointing. I thought it would include things like population density and stuff like that. Okay, that's all right. There is enough information here. We can see. We're going to look at only going to look at the numbers in miles. Okay. Total here in miles. Okay, so here we go. Let's see. So let's fire up over here. Over here. Plug in beta. Notable. Prompt perfect. That's an interesting one. Okay, so now we got this. There we go. Okay. Because we're now using Notable, let's see if it actually recognizes the projects. Huh. I don't know what that means. Maybe it means we have to come over here. So what we're going to do is come over here. Open this up. Okay. Accessing plugin. Okay, that could mean that there's a problem with ChatGPT's plugin use. If that's the case, hey, guess what we'll do? We'll just have to use code interpreter. Okay, plugins, notable. Okay, authorization error accessing plugins. So I don't know what that means. Let's try one more thing. Now, if this works, if this doesn't work, we really are in trouble. Code interpreter. Okay. So I don't know if it's that's sunspot totals. Let's see if we got anything here. I thought at some place I created a folder for Okay, well, let's do things the hard way then. Let's come over here. Let's update a database. We also needed to just go ahead and probably create a Git repository for the information. Yeah, I'm not sure why that's not working. We may need one. Okay, let's do this. Let's do things the tidyverse way, okay? We did that. Then we just do this. Right? Let's do this. Let's do this. Then let's come down here, DB write table. So there's the Tuesday data. Okay. Now we're not actually going to use it. I'm just doing it to get the data back to where we need it to. Let's see. And there isn't any dates, I don't think, is there? Just a year. Oh, okay. So we have to come back over here then. Let's see. Convert this. Because, as we know, SQL Serverlite or SQLite doesn't have a date type. As a matter of fact, I don't think it actually has any enforced date types. Okay, good. Now let's come back over here and do admission. So we should be able to take this now. And change this. Come up here. Load all this. Run the con. And save these. And while we're sitting here, we might as well just go ahead and take a look over here. Should we get tricky and say, you know, well, we have a couple options here. We could simply continue with, you know, database side of things and use Azure, you know, Data Studio to do some visualizations. It's always a possibility. TidyTuesday. Here we go. Oh, shoot. Let's do something a little crazy here, shall we? let's come over here. Let's say admission I wonder if this will work. So we might as well just, while we're here, let's just do a quick visualization here. Let's just count the number by mission year. Let's say interesting. Okay. So now we got our data. With a mission year. Now there's a couple things we can do here. There's a couple things we could do here. We could stay, follow along on the hang on just a second, I'll give me something to drink. Okay, where do we leave off here? What do we want to do? So we could come back over here. was I thinking? Oh, we need to export the data. And for this exercise in futility, we're actually going to export it as a Excel, okay? So we're going to say DXL we got to say right underscore. No, we need to do a right Excel, don't we? Right? So we're going to say STATS. Okay. Comma. I think we can simply say let's see if this works. That didn't take long, did it? Let's see. Oh, man. Now we're going to do a little data wrangling right here, just for the fun of it, okay? We're going to get rid of all the square kilometer numbers, okay? Because we don't care about, this is the U.S., we don't care about, so the demonym is the name of the citizens, Hoosiers, or Indiana, okay? So we'll come over here now. So the question is there some missing emission dates? Yeah, some of those things there don't make a lot of sense, do they? There's nothing. There's 50 rows. Now, that's interesting. All those dates there look correct. All those dates look correct there. Well, this certainly is kind of annoying. Let's try one more thing then. Let's come back over here, and let's write a CSV file then, and then import the CSV file into Excel. See how that works out. As you recall from your DOS days, that the dot forward or backslash says looking to put it in the current working directory, and that is the data directory, okay? Oh man. Oh man. Oh man. And we say use number. So that was the trouble. For whatever reason, some of the dates were entered wrong. And that's why I totally screwed up. But that's okay. As long as there isn't too many of them. The good news is there's only 50 states, right? Let's see, let's do a save as then. Data, save as, spreadsheet. So right now it's still a text field, okay? Let's do a trim. Oh, let's do this. I don't understand why it would spill beyond that to the spreadsheet. Oh man, why did it do that for? Hmm. Don't save. No, you know what the trouble is? No. Now this sure looks like it. So anyway, we're going to start with this. And we're going to get rid of the kilometers data. Because this is America, we don't care about no stinking kilometers, right? Let's move a mission year up to the front. Now, I just don't care about that either. Capital city, Montgomery, largest city, population. See, why is that like that for? How come those aren't lined up? Of course, the trouble is it's actually being stored as a 0 instead of a 02. Okay. Now, total miles, total land miles. If we were to divide the population density, okay, that would because we only care about land density, right? If we were to divide population by square miles, that should give us the population density, right? Now again, we could do this. Let's move this also. Not a really good reason for it, let's just move it also. There. Alright. Number of representatives. We could count. All right, so we're going to say I presume this is population in millions, maybe divide by let's do this. And then let's come over here. Control C. Paste values. So even though, so how do you change the actual number? Can you do a round or something like that on it? We could probably fix that later on. So let's go over and save this. Okay. And what the heck? Let's come over here to GitHub. Create a new thing. Let's call it
Todo meu axé deseja você, Dona Maria. Todo meu axé deseja você.
So we're about this 49 minutes, and we're almost to the point where we're going to be able to decide what we want to do with the data. There's this, you know, I don't know if it's me or not, but GitHub is really running slow this evening. All right, it's really running slow. This is really interesting in a way. I mean, I don't understand what's taken so long to do this. Let's go over here. I find it just as easy to create a column from the command line as this from above. Okay, good. So we come back over here now. Do this. Let's just do both. That way we have the raw data. I'll be right back. I go to the little boy's room here, the little data analyst room. So now, let's create a new file for our let's see some. No, let's don't. Let's just call it right here. We should of course, you know, update the update the Does it go list all the states? And so on. Thank you so much. Okay. Oh, and here's the thing that's kind of strange. Population density. Yeah, so it's all in square miles. Okay. Ah, yes, the ever popular uh, descriptive statistics. Now, you know, there's a difference between descriptive statistics and EDA. Well, there certainly is a relationship between population and the number of representatives, right? Because the number of representatives you have depends completely on your population. A new feature to the dataset, the land to total ratio. This feature represents the ratio of the state's land area to its total area. For example, Alabama has a land to total ratio. And what you notice is it added this on its own. Okay, that is not part of the data. The population density is mine, but this is interesting. Okay. For example, Alabama has a land to total ratio of approximately 97%, meaning 97% of Alabama's total area is land. Now let's perform a brief analysis of this new feature. Let's come back up here first of all. Let's come back up here. See what this says up here. Data cleaning, summary statistics, analysis, feature engineering. Feature engineering. That's a put feature engineering on your buzzword list, okay? Because that simply means you take existing data and you create a new column or new data from it, just like you did with the total land ratio, okay? Let's start the cleaning. There's no missing values. Now let's calculate some summary statistics for numerical columns. We'll look at the mean, the standard deviation, the minimum value, the quartile, the median, and the maximum value for each column. Okay, so here we go. Emission year is not that important. The average year of emission is 1839. Okay, so that's nice. Population, this is really interesting. The average population is approximately 6.6 million, with the standard deviation is 7.4 million. This large standard deviation suggests that there is significant spread in the population in different states. The smallest population is 576,851. The largest is 39.5 million, which is probably the New York or California. Total area. The average total area is approximately 75,933 square miles with a standard deviation of 97,300. The smallest area is 1,545 square miles. The largest is 600. You know what? For you folks outside of the U.S., the largest state in terms of land size should be Alaska. Okay. All right, should be Alaska. The largest land area is around 70,636 square miles. The largest land water area. Let's see. The average water area is approximately 5,296 square miles. Number of representatives. The average number of representatives is 8.7, with a standard deviation 9.7. This large standard deviation is such that the number of representatives varies significantly among different states. Okay? Population density. Here we go. The average population density is approximately 206.5 people per square mile. The least population density is 1.2, which is probably Alaska also. Although it could be. Now let's proceed with exploratory data analysis. Let's do a correlation here. Emission years, not really important. Population. Well, there should be a correlation between number of representatives and population, which there is. Okay? So that's to be expected. There's a positive correlation between land area okay. The heat map above illustrates the correlations between the numeric features in our data set. Population 2020. The number of representatives. As expected, the two variables have a high correlation. Yep, 97. This makes sense as the number of representatives this state has in the House is directly proportional to population. There you go. Total area, land area, water area. These three variables are highly positively correlation with each other. This is expected as a total land area state. Population density. Let's see here. Population density and numbers representatives. This is moderately positive correlation, 0.6 between these variables. Yeah. This suggests that states with higher population densities tend to, yeah, that's absolutely true. Population density and total area. These variables are negative correlations, shows that larger states tend to have lower population. Yes, that's absolutely true also. What we got here now. Now let's look at the distribution of these features. The first one is population counts, total square areas. Interesting. The histograms will show that the distribution of four numeric features in our data set. Here's what we observe. Population 2020. Most states have a population of less than 10 million. Okay. That's interesting, isn't it? It really shows you how lopsided California and New York is, don't you? There are 10 million. There are a few states with a population greater than 20 million, with one state of population close to 40 million. Total area. Most states have a total area of less than 200,000 square miles or more. Most states have less than 20 representatives. Population density. Most states have a population density of less than 50,000. I wonder if we could do a map with population density. Now let's perform some feature engineering. One interesting feature we could calculate is the ratio of the land to the total area. This could give us some sense of how much of each state is covered by land. So we've been at this about an hour, and you can see we spent the first probably 30 minutes doing our data cleaning, right? And we have one feature to show for the histogram distribution, land to total ratio features. Most states have a ratio between 0.9 and 1.0. Okay, good. Indicating that the vast majority of the area is land. There are a few states with significantly lower ratios, suggesting that there's relatively large water areas. Now let's look at how this new feature correlates with other features in the data set. The land to ratio feature shows the following correlations with other features. Emission year. This feature has a positive correlation, a little bit, with the emission year, suggesting that states emitted in the Union later tend to have a higher ratio of land to total area. Population, there's a negative correlation, a small league, between population and land to ratio. Total area and land areas. This feature shows a small positive correlation with land ratio to land, indicating that states with large land areas tend to have a higher ratio of land to total area. Water tendencies, population density. Okay. Yeah, we're going to put you to the test. For any map, we typically need geographic data. We can. Okay. Well, you already did. Sorry about that. Okay. Now, if we were doing a better job of this, we could say, hey, go out and get the geodata for the states. Okay, and combine it. Okay, let's do this. So we want the U that they're emitted inside the bar. So Alaska and Hawaii were both allowed into the Union in 1959. Interesting. Now, we should be able to create a Word doc or something with this, but I haven't been able to get that to consistently work, okay? And that's the trouble. I can try one thing. So let's try this. Oh, it did it one time. Okay, it did it one time. Okay, see, I don't think it's actually listing all the plots. more. So we can now take this. Now what's interesting, it didn't actually create a file, did it? Not at least anyway. So what do you think? What do you think about ChatGPT and Code Interpreter? Okay. Use I have no idea whether this is going to work or not, by the way. Let's see what happens. Oh, wow. Well, it almost worked. If there's a lot of commands. See, I don't understand, cannot convert string to float. I don't understand what the problem was there. Okay? Don't know what the problem was there. But anyway, you know what? It did in fact run except for an error. I mean, it ultimately, it goes through and says, oh, I got an error. I'll just keep on going. So it apparently produces a dashboard for each section, which is why the first section completed. They said there was problems here. I don't know, what the problem with Alabama is. Unless, of course, there's something funky going on with the columns again, but I don't think there is. I don't know. I mean, it could be, for instance, there could be most of the time there's a comma someplace in a word that changes the division between the columns, so to speak. So if it said Birmingham, comma, Alabama, well, that it could interpret Birmingham, Alabama as being two separate columns, which means that Alabama is being pushed into another field. But you know what? Hey, a little over an hour and a half, not a bad night's work. Not a bad. Once again, we continue to see the real power of this type of AI tool. I mean, and remember, here's the thing: the stakeholders don't care how we get the data they want, as long as we get it when they need it. That's all that matters to them. They don't care about, oh my gosh, maybe what about and they don't care about the moral and ethical question whether this is cheating or not. All they want is their information. And if we can use this to get the information to them